Hello, folks. So, today we'll be finishing up Chapter 2, and it should be a short video, but we're going to talk about molar masses and Avogadro's number, and essentially how we're going to deal with atoms in regards to the math of them. Go ahead and get started. So, when we want to count atoms, when we're counting large number of objects, we often use certain unusual units, such as a dozen. Everyone should know if I talk about a dozen is a number that represents 12. I can say 12, I can say 3 dozen eggs, and you immediately know, oh, that's 36 eggs. If I look at a gross of an object, that is simply a dozen dozens. It's 144. Bought a gross of eggs, that'd be 144 eggs. If I brought 2 gross, it'd be 288 eggs. We can look at things in terms of bales, reams like a paper. Google was actually a number that was supposed to represent 10 raised to the 100th power. Basically an uncountable number, which is where the search engine Google derives its name. Or a myriad. A myriad is another counting number that actually has a true number associated with it. Well, when we're counting atoms, we will often use a counting number called a mole. Mole spelled in the same way as that small furry critter that terrorizes your yard and puts holes in it. However, when we write the unit, we will often abbreviate it by cutting off the E to spell MOL. Now, there's a reason why we don't have MO or M. I don't know why we cut out the E, but a mole is abbreviated MOL. But so when we talk about a mole, just like I say 1 dozen is equal to 12 of an object, 1 mole is equal to 602 sextillion, 200 pentillion of an object. It might go a little bit further down for the true number, but 6022 times 10 to the 23rd is usually what we abbreviate it as. So if I want to talk about a certain amount of atoms, a mole of atoms, we know it's 6.022 times 10 to the 23rd of atoms. This number, this conversion factor, is known as Avogadro's number. Avogadro's number, we'll say, is 6022 times 10 to the 23rd atoms per mole. This is named after an Italian scientist by the name of Amedeo Avogadro. Well, he didn't directly find this number, but he did the research with gases that would show that we can treat a volume of gas similar to a quantity of the atoms of gas. That I could react these volumes in whole number portions in the same way as you could react atoms. And so we end up recognizing him for his work, and we name Avogadro's number after him. But we will typically use this number, Avogadro's number, to convert atoms or molecules into moles, or moles back to atoms or molecules, using the process of dimensional analysis and conversion, knowing that 1 mole is always the conversion factor. 1 mole is this many atoms, or 1 mole is this many molecules. You must always convert through that number. So let's look at some simple work before we try some of our own. So you'll start by setting up whatever unit we're given at the initial stage as a fraction over 1. Why do I do that? Of quick reminder, is so that we know what is in the numerator and what is in the denominator. So when we multiply out, we know how to cancel. Next, we will multiply by Avogadro's number per mole in such a way that it will cancel out the starting unit. So take, for example, I want to know how many molecules of CO2 are within 5 moles of CO2. So I'd start with our 5 moles of CO2 over 1. Avogadro's number means I need 1 mole of CO2 on bottom to cancel with our 5 moles of CO2 on top. And so the molecules is 602 times 10 to the 23rd molecules of CO2. So I'm multiplying my way across. 6 times 5 is 30. So converting this back into scientific notation, we would have 3.011 times 10 to the 24th molecules of CO2. If I was to type this into my calculator, I would do 5 times 6022 times 10 caret 23. Or I could do 5 times 6022 double E 23. Either one gets this into the proper answer of 3011 times 10 to the 24th. And it should read, probably in your calculator, it might either read 3011 times 1024, it might read 3011 E24. Because no matter what, your calculator does not have enough digits to show all the numbers. Say I want to turn the number of atoms of carbon and figure out how many moles would that be. If I had 3.18 times 10 to the 25th atoms, so I'd start with that number, atoms of carbon, over 1. So I'd need to set up Avogadro's number on bottom. The reasoning behind being is atoms of carbon would cancel atoms of carbon. And so 1 mole would have to go on top. So one thing to watch out for is when you type this in. My answer should be 52.8. However, we need to make sure we divide by the proper thing. So if you just type this in, I'm going to go to the document camera real quick just to show you what can happen if we're not careful when typing this in. So if I type in this, 3.18 times 10 caret 25. So I got that. If I divide this 6.02 times 10 caret 23, I get a number that is big. Very, very big. That's because even though my mind knows that the math should be this, even though my mind knows the math should be this, if I try to type that into most calculators, you're going to have a bad problem. So that's 25. So how can I make sure to type it correctly? I can type it like this: 3.18 times 10 caret 25 divided by 6022 divided by 10 caret 23. Let's see. So I made sure everything on bottom gets divided. So basically what I did is I split this into something like this: 3.18 over 1 times 10 to the 25th over 1 times 1 over 6022 times 1 over 10 to the 23rd. That's one way to do that. I can use parentheses. 3.18 times 10 caret 25 parenthesis divided by parenthesis 6022 times 10 caret 23 parenthesis 52.8 again. So notice I put the top part in parentheses and the bottom part in parentheses. Or the last thing is, you see this little, you may not be able to see it too well. Let's see. Zoom in. Can I autofocus? I have a button right here, the EE. So if I type that in, 3.18 second EE 25, and I then divide by 6022 second EE 23, it would be just like I typed in the parentheses. That double EE links the 6022 to the exponential 10 to the 23rd. That the EE links the 3.18 to the exponential 10 to the 25th. All these things can be done to make sure we type this in properly. Please make sure, because it's so easy to screw this up unless you're familiar with these tricks. So, last slide. When dealing with the moles of atoms within a compound, we're going to look to the formula unit. So sucrose has a formula unit of C12H22O11. So one molecule of sucrose contains 12 atoms of carbon, 22 hydrogen atoms, and 11 oxygen atoms. 1 mole of sucrose would contain 12 moles worth of carbon atoms and 22 moles of hydrogen and 11 moles of oxygen. So with that in mind, if I had 7 moles of sucrose, I could say, well, that'd be 154 moles of hydrogen, which is 7 times 22. I could convert that into atoms of hydrogen by multiplying by Avogadro's number, which is 9.27 times 10 to the 25th atoms of hydrogen. If we keep these things in mind, we can easily do these conversions. So we are going to be able to convert moles of a compound to formula units, which is like a molecule. We can calculate moles of a compound to moles of an element by looking at the chemical formula. And we can calculate from moles of an element or formula units to atoms of an element. So Avogadro's number and our chemical formula will allow us to do this. So just keep that in mind. But this is the last slide for Chapter 2, so that's where we'll stop for now. Thank you for your time.